Morning, everybody. Djokovic, calendar grand slam. Okay, y'all want to write down what I mean by lattice point. Lattice points in this context are just integer coordinates. Okay, so 0, 3 would be an example, 0 being an integer. And also, just another example, let's say -2, 5. Okay, all of the numbers you see are integers. And so both of these ordered pairs would be considered lattice points. Okay. Now what we're doing now is we're trying to find all the lattice points on this particular graph, which you can see will be tantamount to finding when the radicand is equal to a perfect square. So by the letters that I'm using right here, we're actually looking for something like this. Square root k squared equals to k. Right? So if we can find the k's that do this kind of thing, we'll be finding lattice points. All right. Now below you can see what I've done here. I set the radicand x squared plus 16x plus 111. This is a radicand of this equation right here, equals to k squared, and we take k to be a non-negative integer. Now the rest of this is just some neat stuff dealing with completing the square and then creating a system of equations where you have some cancellation going on. Notice that, let's see here, 8 squared, what makes this fly is 8 squared plus 47 equals to the 111 you see over there. Okay, now, so what that does though, when we do the good old Michael Penn flipperoo right here, notice how we just bring the k squared over and the -47 over. We just swap them, okay? That leads to a difference of two square circumstances. Notice this left-hand side is the difference of two squares. This would be a plus b right here. This would be a minus b right here, okay? Now, the way we continue here, you actually can, due to the fact that 47 is prime, right up here, 47 itself is a prime number, right? That means it only has two factors, namely 1 in itself. And that leads to some, that minimizes the amount of computations you have to do. Now, so what we can see right here is -1 times 47 is equal to -47. So we can set the first factor equal to -1, second factor equal to 47. And the thing that happens right here is when you sum, you see how these k's self-eliminate? So we actually sum these two equations. And when you sum these two equations, -1 plus 47 is 46, and then all that's left standing on the left-hand side is 2x plus 18. This leads to x equals 15 and k is equal to 24. So we see that the way we set this up here, we have 15 and 24 is a lattice point. Now you would expect a little bit of symmetry here since it is a quadratic up there, you know, and a quadratic has a vertex. So now it's tempting to stop right here and say this is the only lattice point. This is a lattice point. Okay. Can we abbreviate this thing in a fashionable way here? LP. Not linear programming, but lattice point. Okay. Now, y'all, what we do right here is just literally swap 1 times -47 is also the -47 you see right here, right? And we know we can stop there because 47 is a prime number. Otherwise, you would have to go through all the divisor pairs, okay? It's not too much work, but it's just a little extra work. And anyway, when you go through the work there, when you sum these two guys up, you get -46 on the right-hand side. You subtract 16, you would get -62 divided by 2, you get -31. So that's what I'm talking about on the symmetry. You see how we had the 24 happening here and also right up here. You know, and that's, if you understand, I mean, the quadratic formula is a parabolic shape, right? And you have that type of symmetry going on. So what you end up with is, now the so-called vertex under the square root function gets shifted around a little bit, but you still have symmetry. Okay. Now, so the last LP, and that means there's only two of them, -31 and 24 is also an LP, right? Lazy guy here. So those are the two solutions. And again, you can take, let's see if I can remember. So 1524. I tried to make the numbers big enough to where people couldn't just guess and test. These type of problems are notorious, where people just make answers like 5, 6 or something, and it's easy if people just sit there in about a minute, just guess. This one's a little bit tougher than that. And then what do we got? Minus 3124. Okay, those are the only two solutions. And that's what the problem called for, right? Find all lattice points. We found them all. These are the only two. A good question would be, could you create an integer Radicand coefficient type thing here where you didn't have any lattice points? That's interesting all by itself. I don't think so. I think you're always going to have at least 2 lattice points. I may be mistaken on that. But anyway, hope you guys enjoyed. And again, Djokovic calendar grand slam, baby.